Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 19 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so we have a rectangle. It's graphed on the coordinate plane. The center of the dilation is 0, 0. That's going to be very important. Then we have the vertices of the dilated rectangle. So you know what? Let's see if we could get a little bit of a representation of what this looks like. So let's draw. We'll do it right here, right down the middle. See if we can draw a coordinate plane here. Let's see if we can graph some of these real quick. And I'm going to decrease the transparency. I just want to barely see what's going on here. All right, so the original rectangle I will put in, green here. So 12, 9. So if we were to graph that, right, we would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12. And my 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9, way at the top, right? So it's going to be right up there. And then 12, 9 down is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so what I want to do is I want to kind of grab this. And you see we're going to need a negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so we're right there. And then we could just kind of put it right up there. So that's my original rectangle. Okay, if I wanted to connect the lines, we're not going to be able to see it up there, but we can at least see it right here. All right, so that's my original rectangle. If we drop the transparency, right, there we go. Now, what happens with our dilated rectangle? Okay, it gets a little bit smaller, and that's where it gets a little bit interesting. I'll do that in blue here. You notice that the dilated rectangle doesn't go out as far. Okay, it only goes to 8, negative 6. So what does that look like? Now let's decrease the transparency. We're just going to go to 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Then we're going to go to 6. 1, 2, 3, 4, 5, 6. And a negative 6. 1, 2, 3, 4, 5, 6. Then a negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we've got another one right up here. And that's our smaller rectangle. Now, why take the time to do all this? Because you know what? If we visualize it, then it's going to be a little bit easier for us to find the rule. Because look what it says. Rules apply to the original rectangle, that's one in green, to create the new rectangle. Well, what happened? It got smaller. It got a lot smaller. It went from out here into right there, so it shrunk. So what happens when we dilate? Well, when we dilate, it either grows, which means we multiply by a number, right, larger than 1, or it shrinks. Right, we multiply by a number less than 1. So if we wanted to look at some of our answer choices, we could eliminate 3 different answer choices. Look at B and C and D. C and D are wrong because they're not multiplying. They're adding or subtracting. Now, B, okay, that actually is the one that looks okay because it's less than 1. It's the A that it's greater than 1. Right? So that means it's growing, but we didn't grow it, we shrunk it. So B looks a lot better. Now, if you didn't want to draw that, there is another way to solve this problem. Right? You could have just taken your new dilation, let's take this x-coordinate 8, over the original 12, right? And what does that simplify to? 2/3. You could have done it with the x-coordinates as well, or the y-coordinates as well, 6/9 equals 2/3, right? That lets you know it's a ratio or scale factor. So my answer here is B.